Hey guys, welcome to Let's Talk Algorithms. This is Venkatesh and today we'll be solving the problem insert delete get random in O of n and duplicates are allowed. So there's a different problem like very similar to what we are looking at right now, except in the previous problem duplicates were not allowed. That simplifies a lot of things, and it was a medium level difficulty problem. So as you guys can see, having duplicates increases the complexity of the code, and that is why this has been tagged as Leetcode hard. Alright, let's look at the problem. Design a data structure that supports all of the following operations in an average of one time. So no duplicates elements are allowed. I know that, like the question title says it, sure. So we need three operations. One, insert an element, basically a value, to the collection, removing an item value to the collection if present. Get random returns a random element from the current collection of elements. The probability of each element being returned is linearly related to the number of same value to the collection contains. So it's basically saying, let's make a small workbook here. Right. So this is a workbook. We'll see what this problem is asking before we start coding. So as you guys can see, insertion is basically a regular insertion. Here you were inserting 1, and then later on you insert 1 again, and you insert 2, and then it's asking for a get random. So the problem says that when it does get random, basically 1 should have 2 by 3 of the probability and 2 should have 1 by 3 of the probability. And if you remove 1, you basically remove one entry of the 1. When you remove 1, it doesn't mean that you have to delete both occurrences. No, you have to delete only one occurrence. So if you have already solved the problem, previous problem, you would know what data structure to be using. If not, don't worry about it. So whenever you see anything remotely off 1, I mean, the only data structure or the data structure you would be recollecting is get hash map, right? Hash map provides O of 1 insertion deletion, amortized complexity. So we know that we want O of 1. So let's assume that we need a hash map. So hash map actually works, but what happens when there are duplicates? How are we going to track duplicates? So in the previous problem, when there were no duplicates, the way we were storing is an integer to integer hash map, which basically does this following. Whenever you have to insert a new element, you insert the following element, and the basically a final array, something called keys. So at the time of the insertion, you store the length of the array basically as a value. So if you're inserting 2, then you're inserting 1 here as a value. So the keys will have 1, 2. Same thing, if you insert 3, it will have length 2 before insertion, right? So it's this value is basically length of keys before insertion. Why we are doing this, I'll tell you later when we are dealing with removing an element from the map. Alright, so this is how it will be, but the problem is this question allows duplicates, right? So what do we do, like when there is another 1 here? Do we store the 0 or do we override, right? So what we'll do is basically, instead of overriding or we will have a list here which basically stores. So if I is inserted again here, the length of the keys before insertion is 3, so you will have 3. If I has to be inserted again, you'll have 4, and if we are inserting 2 now, So we'll have 2 and 5 because the length of the keys before insertion is 5. If you're inserting 3, we'll have basically this 2 6. So this is how our data will look like. Let's bring this side by side to have a better understanding of how the data structure would look like. Alright, so this is how our keys would look like after insertion, since duplicates are allowed. And this is how we store all the elements and their occurrences, like where exactly was it inserted in the. If you closely look at it, basically we are storing the index of the array, right? We are storing 1 at 0, there's another one at 3, there's another one at 4, right? 2 at index 1 and 2 at index 5, 3 at index 2 and 3 at index 6, right? So we are basically storing indexes of the respective elements in the hash map. So if you see here, this is a list, right? What do you think is the best data structure? You can always go for an array list. I will be using Go. So in Go, I would use a linked list because we want a O of one addition and removal at the start and front at the end. I don't need an indexed read. So if you're looking for a big O of one and a big O of one insertion or deletion time, you could use a linked list. So now our data structures would look like this. Structure. So map, which has integer to linked list, and an array list, basically a slicer array list for storing keys. So what are we going to do? Every time you get a new element, you see if it exists in the map. If it doesn't exist, then you create an entry for 1, and if there is a no linked list already present, then you basically create a linked list and assign the value, basically add the value to the list. If we are looking at removal, this is the only complex operation actually here in the whole solution, because what happens is when you remove, you want to do it in constant time. Let's say you're removing 1, right? So if you are removing 1, how are you going to do it in constant time, right? When I say constant time, it doesn't have to be one atomic operation. It could be like k atomic operations where k is very small. So the way we are going to do is, every time we have to remove an element, we look at the last. Basically we look at a random index in the thing. Like let's say we are removing 1, remove 1. The way we are going to do is read the list associated to 1 and read the first element and remove it from the list. And then what are we going to do is, you can check in the keys if the last element is basically 1. If it is not, what are we going to do is basically copy the last element over. Let's copy this array. Copy the last element over to 3, basically the whatever index we picked here, and remove the last element. And removing the last element is big of 1 because we are using a linked list, right? So that is the reason I picked a linked list for a value of a map. So every time you do something like that, you now the indexes of 1 will have 3 and 4. So we have to do one more thing after we delete. Since we copied 3 from index 6 to 0, we have to remove the last index of 3 and add that new index, which is basically 0, at the start of the list. This is because we want to maintain the large index, the large value of the large index always at the end. That is why when we remove from the end, and when we have to add, we always add at the start. So these are the two operations you have to remember to basically make the remove work in O of n. If you look at the total number of operations, what we are doing is we are basically copying over the last element to some index and removing the last node, because we are using a linked list. So ideally it's like 3 operations which still big of one, on an average or complexity. So let's all comment it out, start with the solution. I'll be using Go. It's more verbose than probably like using some other language. So if we are looking for something else, you could use a similar logic but in a different language. Let's start with the data structure. We can call it randomized collection map. I just take the first letters of all these things and call it RSM, randomized collection map. And R is a map with an integer, and list as a value, basically pointed to a list because we wanted to use it. So import Go, we have container list. Another package we want to solve this problem is random, and Go it's math.rand. Random because we have to give a random element and big O of 1, so you could use a inbuilt function which randomizes the retrieval of an element from a list. We just pass the length of the list, and if the list size is 0, we basically return -1. So we import math.rand from container list. So typo. So we need keys, which is basically an integer, right? Alright. So in the constructor, we are going to return an instance of this thing. So make map of int star list about list. This is the map, and so we also need keys right here. For keys, we are going to say make of int comma 0. Alright, this returns you an instance. Let's start with the insertion. So what you can do is you have to first check if this dot rsm is our map of value is present. If it's not present, let's check for the negative cases. Let's say if we don't have it, what you could use this, you need to return actually inserts a value to the collection, returns true if the collection did not already contain. So let's have var is present boolean. You can just say like this. Basically, if it's not present, what are we going to do? We will basically, okay, if it's not present, we have to put the value in the map. This dot rsm value. What are we going to do here is create a new list. So the way we do is list of new. And once you do that, we are going to add the value rsm value dot push friend, basically pushes the value to the friend of, what we have to add, right? Length of the keys at that point. And once we do that, we will add the actual value to the keys. So append this dot keys value. What we just did is basically put 1 in the map along with an index, for example 3, in our case it's 0, and we put 1 in the keys. So the first operation does this thing, putting it in the map, and the second operation does this thing, putting the value in the keys. Alright, so now we have insert. Alright, removal is little tricky, but removes a value from the collection, returns true if the collection contains the specific element. So straight away we can look for worst case scenario, which is basically the value not being in the list. So if it doesn't exist in the map, that means we don't have an element. So not okay. If it's not okay, we return false. So that does the short circuit exit part. Now let's say we remove the first value. So we retrieve from the map this value set. So when I say retrieve this value from the value set, remember we removed 0 here, but before removing 0, this was the set, right? 0, 3, 4. So when we do value set equal to this dot map of value, we'll get the value set. We get this 0, 3, 4. So once we have that, what we are going to do is we retrieve the first value, right? I told you we're going to need the first value. So just call it location. So we need value set dot remove. So before removing, we need the value friend of value dot of int. So Go doesn't have generic, so it assumes it has an interface basically, which we have to pass the data type for it has to, for it to resolve to a certain type. So now we have an index which is 0. So location now has 0. What we are going to do is, once we have the location 0 in hand, we'll just remove it. So how we're going to remove it? We'll say value set dot remove of value set dot friend. So the friend method returns the first node in the list, and the remove method removes that. So once we remove this, remember we are operating on a local variable which we retrieved from the map. So let's assign it back. Value is equal to value set. So what does this part do? Get the first index from the linked list and remove it. So now that we have the value, check if the location we retrieved is less than the length of these dot keys minus 1. We need this because we have, our plan is to basically swap the last value in the keys with this index, right? So we have to make sure that the list is like the last index is not like greater than or basically less than the location we retrieved. So let's call it last one. So let's retrieve the last value of this last one from the keys. We are retrieving the last index value, which is Now before removal it's 3, right? Yeah, now last one will have 3. Once last one will have 3, what we will do is we'll assign keys of location is equal to last one. So this operation, what it does is it removes 3 from it takes 3 and assigns it at 0 index. We didn't remove 3 yet, but we are going to remove it now. So once we have the assignment, we'll have to remove it. So last one list. So we are going to retrieve the list for the last value. So list for the last value is basically 3, right? For 3, for example, we have 0 and 2. Like, I think ideally it was just 2 initially, 2 and 6, right, initially. So this gives last one list is basically the 2 and 6 now. So what are we going to do? We are going to remove, copy, paste, remove dot back gives basically the last node. So once we remove it, remove last value in the list, since we copied it over. Alright, so once we did that, what we'll do is we'll push the new location, right? So we removed 3 at index 6, but we kept it at 0. We have to tell the list that the new index is at 0. So push the new index to the list. So the last one dot list, you can basically push friend of location is the index, and then once you do that, you can just assign the value last one. Since we are operating on a local copy, we assigned it back. So if you haven't observed, we didn't remove the value from the actual keys yet, so we are going to do that now. We can just do by this dot keys equal to this dot keys of length of 0 to length of this dot keys minus 1. So this is Go slices. This is called slices in Go. It basically operates on top of arrays. It's like kind of array list, not exactly, but it's really fast. So once we remove that, so we can check for one corner condition, which basically if after removing it, if the value is basically doesn't have any values in the associated list. So for a given value, the associated list doesn't have any values, we are going to just delete this. So the delete method and Go gives you this functionality to just delete a certain key from a certain map. So at the end you return true. Alright, so yeah, one more method. We implemented insert, we implemented remove. Now we are going to implement the getRandom. So first let's check for the length of the keys. If length of the keys is equal to 0, you return -1, because you can't return a random value from the empty list. If not, just return these.keys. So we need a random index basically from 0 to the length. So Go has rand int n of length of this.keys. You're just basically saying to the random function, give me an integer from 0 to this value, which is basically the length of the array from between 0 and these dot keys. This doesn't include the end value, so you will never have the index out of bound exception, at least here. And yeah, this basically randomizes the index. Let's run it. Pretty sure we missed some syntactical stuff, but yep. Line 27, which is basically return now is present. Last one list. So go needs a colon equal to for initialization. Alright, it ran. So don't worry about the get random values. It doesn't expect, like, I mean, when you run it here, it doesn't exactly match, but overall, yep. So it's been accepted, runs in 48 milliseconds, faster than 90% of the Go solutions. I might go check how, I mean, what's the other solution which does 100% stewing, which is what I usually do. Like whenever I get anything less than 100%, I'm just curious, like what people are doing to get it, like to beat 100% of the solutions. Either way, 90% is not that bad, right? And if you have any questions, please feel free to post a comment on the video. And if you like the videos, if you want the videos to keep coming, please like and subscribe to the channel. Thank you so much.